Hi, this is Alix Paultre, and I'm here at APEC 2018 in San Antonio, Texas, with a dear friend of mine, Alex Lidow. I'm really glad you had the time to bother, especially at this time of day. We caught the show early. It hasn't opened up yet, so I've had a chance to grab you, and we can talk some.
It's always fun with you, Alex.
Well, you can literally walk around in this industry telling everyone I told you so. You're the godfather again. You've been talking about wide bandgap semiconductors literally for years. It must be really fulfilling to see everything come to fruition that you've been telling everybody is going to happen.
Well, it's true, although my father always used to say that the future is easy to see. It's just hard to see when it's going to happen and who's going to benefit. So I think it is happening now, and I hope we're the ones to benefit.
Well, I think everyone's going to benefit. That's the beautiful part. Now, obviously, EPC benefits because you've got some really cool technology here. But what I like is that these are real solutions. No longer it's just that here's a chip and do something with it. You've got some serious solutions here. And actually, I'm looking at this. This is the LIDAR situation, isn't it?
Yeah, and LIDAR was one of our first applications because GaN is so much faster than silicon. It allowed a LIDAR system, which is measures the time of flight of light, to become accurate enough to enable autonomous vehicles. And what you're seeing on the screen on the back, it's a split screen. On the right-hand side is a scanning LIDAR system like you see on those autonomous cars driving around. And it's running actually in the top of our column here. And then on the left-hand side is a new type of LIDAR called flash LIDAR, which basically flashes a bunch of lasers at the same time and then uses a camera chip to measure how long it takes for the light to go back. Good for short range, but also very inexpensive. These will be under $100 very soon.
Very nice. Well, then that also allows, and obviously autonomous vehicles is the first thing that pops into people's minds, but this could benefit all kinds of things, presence sensors, robotics, assembly.
Absolutely. You know, it's great because there's nothing simpler than getting an XYZ coordinate of everything that's around you. And that's what LIDAR does. And by having flash LIDAR working in conjunction with scanning LIDAR in a car, you can create a file of the 3D point cloud very easily, which reduces your computation time. Same for robotics, same for autonomous drones and things like that. So I think it is the simplest and the most accurate way to understand your environment around you.
Very nice. Now, I see you've got a demo here, and these are the laser drivers, aren't they?
Yes, so we built two demos here to show how fast and how powerful a pulse we can put into a laser. Now, the more powerful the pulse in the laser, the farther you can see. The faster that pulse width, the more accurate you can see. So if you want to see farther and better, you want a big pulse very fast. So this is showing you a 25 ampere pulse in 1.6 nanoseconds.
That's really fast.
That is as fast as it can get, and it's thanks also to the new TI 1020 driver. So this is really new stuff. Now on the right-hand side, we have a 150 amp version, which can give you that pulse in about 6 nanoseconds.
Now, I'm assuming it's the speed of the device that keeps your thermals down because, I mean, that's a lot of power being pumped through, but you're doing it very rapidly.
Right, we're pumping these things in just a few nanoseconds with a repetition of maybe a few hundred kilohertz. And you can imagine how hot that laser is getting, by the way.
Yes, well, and the fact that you can control it that well, I mean, as you pointed out, the more precise the pulse is, the better the vision's going to be.
You can see faster and you can see farther and you can see better.
Well then, speaking of seeing things, let's look at some of the other nice stuff here. So obviously you've been working on this for a tremendous amount of time. I really think that this is something that is really to be proud of because a lot of companies are doing coplanar drivers and a lot of the packaging issues, but you don't do packages.
Well, we don't do packages, and also one of the problems has been with GaN is that you have to interface a silicon driver IC with it, and that interface takes engineering time. It also requires a lot of skill, so you don't have any parasitic inductances in between. We just put them on the same chip. So we have drivers plus FETs. In this case, the 2112, which was launched at this show, is 200 volt. It has a 40 milliohm FET on it and is the driver completely integrated. Here we're using it to make a CPIC converter that powers this little PC here. As a matter of fact, if I turn it off, you'll see the PC goes dim. If I turn it back on, you'll see the PC goes back on. And this tiny little IC is just 1.5 by 2 millimeters in size. Now, we even took that further. We can go over here, where we put two of those FETs and two drivers onto the same chip. And here it's running a differential mode Class E amplifier to do a Class 3 wireless power in this, and that's just one tiny little chip, the 2115. It has 2 drivers and 2 FETs. And as a matter of fact, we even have a picture of it right over here. So let's take
a look at that picture. It's right here on the edge of the bank. Let's see if we can get our camera to come down and focus in on it a little bit. Right here. Why don't you point out the features on it?
So you can see there's 1 FET, 2 FETs, 1 driver, 2 drivers, all on one chip. And
without a package.
Without a package, it's 1.5 by 2.5 millimeters.
Very nice. So then, let's keep going. We've got something here I thought was very interesting because, well, I mean, you've always been a power guy, all right? I mean, from age-old international rectifier days, you and power are almost synonymous in a certain sense, and I'm really glad to see you've got a really nice power device here as well.
So with our 5th generation FETs, we decided we're just going to show the world that you can't do better than our devices in DC to DC. So we prove with the new 9130 demo board, which is shown here, that we are more efficient, we are smaller, and we are lower cost than any other 48 to 12 volt converter. And we compare it against the highest performance, and we compare it against the most brutally competitive cost-wise. This is 1,400 watts per cubic inch. It is 96.1% efficient, and you can buy that bill of materials for under 6 cents.
That is an amazing performance price. I mean, I can't think of any company that can offer that kind of a performance price ratio.
And it's because with GaN you can do the absolute simplest buck converter configuration. It has the fewest components, it has the least amount of engineering time, and it produces the best results if you use GaN. So nobody can do as well as we can in 48 to 12.
Well, I was looking at this. I see you've got a thermal image right now. The thermals are very good if you think about it. You're cycling it in real time, if I'm not mistaken. I can see that you're going through the load is going through the various on-off states, and it's really impressive, the thermal performance.
Yeah, we're pumping 720 watts for several seconds through this thing just to show what it does thermally, and the temperature of the chip only goes up about 50 degrees C.
Now I notice you have a device there in your hands. Is that the individual building block?
Yeah, we have the individual phases of this also for sale. This is the EPC 9205 that we're also launching here at APEC. It's tuned for 700 kilohertz, it's 96% efficient, and it's 1,400 watts per cubic centimeter. It just doesn't include the controller.
Excellent. So let's go over here. Let's go. Okay. Sorry. Now this is something that I was looking forward to seeing because you've been talking about this in other venues. This is your wireless work table.
This is the desk of the future, hopefully not too distant future. But this is a 300 watt table which has embedded in it a wireless resonant magnetic antenna, and it powers everything you see on this desk. We have all of our little gadgets that we wear on our wrist, but everybody hates plugging it in at the end of the night, or we forget to do it. But here we can just lay it on the table, and sure enough, it'll charge up. Mm-hmm. The computer is being charged, or is being powered. The monitor, as you can see, is being powered directly through the desk. This lamp, this Google Home is being powered right through the desk.
Now I noticed this is a key phone. Is this what is? You actually have an adapter for that.
Right. So Qi is very popular with cell phones, and cell phones are very popular with Qi. So that's great. But Qi doesn't eliminate power cords. Qi requires a power cord. Well, so we just said, well, let's take a Qi adapter and let's just put an antenna on it. And sure enough, we'll power your Qi adapter and it'll charge your Qi phone, no problem. And you can put it anywhere on your desk. So now,
truly cord free.
That's our goal. We want to eliminate power cords because I don't know anybody likes a power cord. We have back here, by the way, these are like nightstands that you might have at home, and they have with them all the different gadgets, your clock radio, a lamp. You can see the lamp's even off the table a little bit. Another one of these Qi adapters. We have a wireless Bose speaker playing here. We have an Alexa playing as well. And all of this was made possible by an antenna that was invented by our own Michael DeRoy. You can see it here. We have nicknamed it the Olympic antenna because it looks like the Olympic rings. But this is a carefully engineered on standard PC board antenna where the rings actually have magnetic fields that reinforce and cancel each other. The advantage of that is it creates a magnetic field that is uniform across this surface, but only about an inch above the surface, and it ends right at the edge, so that you don't have any interference with anything around it.
Any metal on your body or something along those lines.
Right. So we really are cutting the cord. All these things you can see we've eliminated at least 10 power cords here.
Well, I noticed even your display sign is.
That's right. And it really does show how easy this whole thing is. You just put a little antenna and you plug it in where your power goes in, and boom, it's now wireless.
This is I'm really glad you took the time to show us all of this, because from LIDAR to power to home convenience, GaN's really doing it.
I think so, and I think you're seeing here at the show there are many people showing their GaN products, and it's a great thing because GaN is going to crush silicon.
I believe so, or at least in the areas where it definitely outperforms. I'll tell you that.
Absolutely.